Mars. The Curiosity rover is searching for clues about the origins of the red planet. It confirms the presence of oxygen and nitrogen isotopes hidden in the rocks and soil.
We use isotopes to try to figure out the history of planets, partly because they are immune to many of the changes, the chemical changes that occur when you have things like collisions and so forth. Isotopes, the relative abundances of these isotopes are like fingerprints.
Curiosity confirms a unique mix of isotope fingerprints. The isotopes indicate that Mars formed elsewhere in the solar system and moved into our neighborhood. Our solar system is full of oddities pointing to an imperfect birth and a malformed evolution. All of our planets go around the sun in the same direction that the sun is spinning. This is the same direction that the clouds within our original nebula began to rotate. 6 planets spin around their poles in the same direction. For them, the sun rises in the east and sets in the west. Yet 2 planets spin the opposite direction. For Venus and Uranus, the sun rises in the west and sets in the east. Uranus not only has a retrograde spin, it rolls on its side like a bowling ball. At Neptune, the icy moon Triton orbits backwards, opposite from the direction of Neptune's spin. Do these planets spin backwards because they were rocked by titanic collisions in the past?
So we see evidence in the architecture of the solar system for not only collisions, like Earth's moon, and the fact that Venus is rotating in the wrong direction, and Uranus is on its side, and so forth. All these things are attributed to collisions. We also see in the asteroid belt and in the Kuiper belt, the outer asteroid belt, if you like, we see that the orbits of these things look like they've been disturbed.
Closer to home, our own Earth has an inexplicable 23.5-degree tilt. Its spin axis is radically misaligned from its magnetic pole. And our moon is comparatively large for a planet our size. Now, a new theory may be able to explain many of these oddities. It is called the Grand Tack hypothesis. Four and a half to 5 billion years ago, a gas giant planet arose inside a primordial disk of gas and dust.
Jupiter didn't just form where it is, but formed and then moved inward towards the sun.
As it spirals toward the sun, Jupiter herds asteroids and rubble.
Jupiter's natural tendency is to drift in slowly through this debris field that it's traveling around.
The inner solar system is also thick with gas and dust. The birth of our planetary system is well underway. Numerous worlds are born in this region, including the Earth. Primordial skies are ruled by chaos. Jupiter's approach destabilizes these planets. Their orbits decay into wildly swinging ellipses. Some are tossed out. Others fall into the sun. Their numbers are unknowable. These are ghost worlds from a bygone age.
Jupiter just causes all heck to break out in the solar system, and all that debris in the outer solar system gets flung inward towards the inner solar system.
And it was a busy time in the very early solar system, and things were colliding with each other all the time.
And then it stopped. Jupiter's invasion of the inner solar system is mysteriously halted. The planet makes a turn, or, in sailors' parlance, a grand tack. Lurking behind Jupiter is a second gas giant, Saturn.
So as Jupiter was migrating inward, Saturn was following it and growing. And as Saturn was growing, it came to have a size that it had a gravitational impact on Jupiter, which became more important than the gravitational interaction between the gaseous disk and Jupiter. They reverse direction. And in a sense, you can think of Saturn and Jupiter feeding off one another and moving back out.
Gravity tugs each passing planet. This transfers orbital energy from one world to another.
All you have to do is exert a very subtle little periodic force at the right time, and you can have amazing changes in the motion of the object you're pushing on.
Once enough energy has been transferred, the planets synchronize their orbits. They are said to be in a resonance. For planets, resonances are achieved and maintained through the mutual push and pull of gravity through the fabric of space. They're a key factor in the continuing evolution